What if you AI could read your documents before answering and even decide for itself when to search and double check its own answer? That's a RAG versus agentic RAG. And in today's session, we are going to see both of these from scratch, theory plus practical, absolutely free. Welcome to NextGen AI with Sai YouTube channel. If you haven't subscribed to my YouTube channel, please go and subscribe it. So, as I mentioned, it's absolutely free. So, no paid API keys, no credit limit. We are going to use both absolutely one of the best framework, that is LangChain, and for the LLM, we are going to use Groq. So, we will first understand the theory and then we'll try to map those theory to our practical things, that is each and every line of code we will try to understand from scratch. So you know that the normal model, that is the LLM model, know its training data, as it's a large language model, so it's been trained on massive data. So as it's trained on massive data, and again those data are private, okay, so it may be hallucinate, because the kind of questions you are going to ask, right, it may gives the answer but it is not the expected answer that you want. And that's what the main problem of plain LLM model. And that's where the RAG comes, that is retrieval augmented generation. I have made a couple of videos on this. Please watch those previous videos, which will help you to sharpen or to revise your knowledge on this. So as this term has retrieve augmented generation, the two terms it's very important. One is retrieve and second is generation. So when I say retrieve, it try to search the knowledge base for the chunks which is more similar to your questions. And then LLM takes those chunks of data and your question and generate the answers based on the retrieve chunks. Now, let's try to understand this basic concept behind the RAG. So first we will try to understand the basic RAG and then we will see how it works practically. So in the basic RAG, as you can see on my screen, the first user asks the query. Those query will encode into the vector format, because we are trying to search the answer from the vector database. So it is very important to convert those query into the encoded format. And for that, we will use the encoder. So once the query converted into the embedded format using encoder, then it will hit the vector database and do the similarity search. Based on those similarity search, it retrieves the context and plus the user query. I hope you are able to understand the till step 5. Let's go back and try to understand again. So user write its own query, which will convert into the vector format using encoder. Generally we call those as embed, and then it hits the vector database to try to fetch the top K document using similarity search. And those similarity search help us to retrieve the chunks which is relevant to my query. And then we'll combine those context, that means the retrieve chunks plus query, and send it to the LLM in our, and this makes up the prompt. So generally prompt contains these two things. The one is a context, another is a query, and those hits to the LLM. LLM understand your prompt, that is, it knows this is what the user query, this is what the retrieve context, and based on his knowledge, it try to do the response. So this is what it say retrieve and then generate, so that whatever answer LLMs gives, it's having the grounded response. And this is what the basic RAG, right? Now, but this basic RAG is powerful, right? As it follows a straight line. It always do the retrieve from the same source. never check its answer. It can't think, and that's where the agentic RAG is more powerful. Because if you look at this this flow, it it asks the query, retrieve the questions from vector database, and gives the response. But it never verifies whether the answer that given by the LLM is right or wrong. Even it will always refer the same database. And that's the bottleneck of the RAG, and that's why the thing come that is called as a agentic RAG. Okay, to analyze the answer given by the LLM. Now, in agentic RAG, it's add the decision and the loop. So first, based on the query, it will check, do I need to retrieve? Okay, which source I need to pick, whether it is my knowledge base or whether it's my open internet, or do I need to refer any tools or API call for this? Is my answer is relevant, whether it's a good or not? And if it is not good, then it again do the loop back. And this is called as the self-correcting loop is what makes your RAG as an agentic RAG. So you adding the brain to your retrieval process, and this is called as the agentic RAG. Let's try to understand all these steps, how it happens practically one by one. So as you can see, the user asks the questions. First, it will rewrite the query. The same start, but now here agent decide whether to retrieve, which source to be picked, create its own answer, and looping back on no, and all these are the 11 steps is going to execute. So let's look at these things. The user asks the question. Now sometimes those users questions are very small, maybe sometime large, or maybe sometime half, right? It's not fully written, it's not fully detailed. So it is very important first, so whatever questions user trying to ask, we should rewrite so that LLM can able to take the decision. So the based on the user query, we first rewrite those query, then update it, rewrite the query. Now based on the rewrite query, we will have the new query that is called as updated query. And based on updated query, agent first check whether do I need more details or not. Don't worry, we will look at the some example. If it's check whether it requires more detail or not, if it is no, then it directly asks the LLM, I do not require any more details, and gives the response. And again it check whether the answer is relevant or not. Again go back to the rewrite query. If it is answer is correct, then it goes to the final answer. For example, if I ask what is the area of the whole world, right, or whole country of any specific country, definitely those area sometime it's already available, the LLM is already known to this, right? So it doesn't require to fetch any specific the, the based on the query we will have the updated query, right? And with the updated query it may do not require any source to check, and it directly go to the LLM, and based on that response it gives the answer. Second, for example, again if it requires more details, then it will check which source does require to retrieve these answers. Now it has a three options. Now again it based on the you can configure which sources you want to your LLM or the RAG agent to be checked. So first it will check your vector database, then it will check tools, and then it will check the internet. So based on the more details, it will decide which sources to use, and then based on the source it will select that source and retrieve the context. Let's say if the asked question is answer is not available in your database, it try for the internet or maybe tools, and based on that it will try the context. Now my LLM has two extra data. One is the retrieve context plus updated query. Now, when you combine those retrieve context and update query, it becomes prompt, and this prompt goes to the LLM. And then LLM will generate the response. Again, the response that is generated, it again check whether the answer is relevant to the query or not. If it is not, then again this loop will follow continuously. Whenever it finds the answer is relevant, then the final response will generate. So this is how the agentic RAG is one of the popular and the productionized way to use the RAG. Now every industry is following this kind of agentic RAG than the traditional, because traditional RAG has a lot of loopholes. So every theory is done. Now let's try to build this from scratch, and let's try to open our editor. So I have created this whole notebook for you. All the things are available. What library we are going to use, everything is available. You can pull this repo from the Git and follow the steps. So what frameworks we are going to use? We are going to use the LangChain, then the Groq to use the LLM, then we are going to use Hugging Face to download the embedding model so that it will convert our query into the encoded format. Then we are going to use the local vector database, that is FAISS, then LangGraph for the agentic RAG. Then we use DuckDuckGo search for the DuckDuckGo search to search on the internet, and the python.env to read your environment variable. Before you start, kindly make the copy of this environment example to environment. Use Groq API. So free limit is available. You can log in. So some free credit is available. Use it, and the free credit is sufficient to execute this code, right? And you can see there are some Python file. One is a RAG, basic RAG, which will help you to understand how basic RAG code is implemented, and agentic RAG, right? But just to understand each line of code step by step, I'm going to refer this notebook file. Okay, so first, before you start again, note that you have to install a couple of library. I would encourage, kindly make. So this is the terminal. Yeah, this is the terminal. You can use always the new terminal. There are a couple of commands that you need to run to start. The first thing, let me open the command prompt. So first you have to run this python mvenv dot space dot nv. So this will create the virtual environment. After virtual environment is run, then you have to activate this virtual environment. For that, you can go to this and then copy the path, okay, and then hit enter. So this will activate your virtual environment. Once virtual environment is done, you have to run this command pip install -r .txt and hit enter, so that all the libraries required to run this code will, okay, it's available in virtual environment, so that you will not see any. So these are the basic steps you need to run. Now if you're running the Jupyter notebook, so please note that you have to install the IPY kernel. This is the command that you can say install IPY kernel. So this is one of the necessary library to run the Jupyter notebook. Oh, I hope now everything you have installed. I encourage, please do along with me, so that this will help you to understand each and everything very clear. Now first we have to import the OS. So this is required to read our environment variable file. Then from the .env, we are going to load the .env, which will load our environment variable. So we have already added our Groq API key into this load.env, and this will read our environment. And then we are going to check whether the API key is available or not. If there is no API key, then we will give the error that set the Groq API first. So let me execute and see whether it's ready or not. Yes. So everything is there. So this will this will gives that our Groq API is set in the environment. Now we are going to use this LangChain Hugging Face embedding to create the embeddings of our input query. Then from the LangChain community.vector store, we will use the face, our local vector database. From LangChain community document loader, we are going to use text loader. So this will help to load the text. And then from the LangChain text splitter, we are going to use recursive character text splitter. So this recursive character text splitter help us to divide your data into the chunks, okay, before storing into the vector database. Now this line will help to load the embedding model. So to load the embedding model, we are using the sentence transformer all mini LM L6 V2. So this is freely available embedding model. It's again a kind of one of the transformer based model which is available in Hugging Face, and it's open source, so you can initiate accordingly. So this will load this model locally. Don't worry, it's not huge and will not consume too much space. And we initiate the heading. Once done that, we have to pass our knowledge, right, to vector database. But to pass this knowledge to the vector database, we have to follow some few steps. As this knowledge base is small, but as you are working on some of the large data, then these are the prerequisite to convert your text document into kind of chunks, then store into the vector database. How you can do it? So as I have this text loader, similarly, if you have PDF, you can say PDF loader. If you have PPT, then you have PPT loader. For different data types, you have different type of loaders. So this loader will load your markdown file of knowledge base, and we are doing the encoding of UTF-8 if there is an encoding is available, and then load. So this will load whole data to my docs. Now let's look at what this knowledge contains. So this knowledge is a very simple knowledge which contains what is machine learning, what is supervised learning, what is unsupervised learning, reinforcement learning, what is neural network, transformer, RAG, embedding, and Groq. So these are simple question answer format, but I believe in reality it is not simple. So please refer the LangChain documentations. All the how to handle for a complex is available in their websites. Now, once the docs is available, we have to divide these docs into the chunks. So how I want? I'm using the recursive character splitter where I'm saying my chunk size is 500. So my whole document divided into the 500 of chunks of length, right? So divide everything data into 500 of chunk size and with the overlap of 80, right? And I'm saying split the documents. So for a document, I'm passing docs. So I'm using this function of split documents. I'm passing docs. So this will divide my data into the chunks of 500 with the overlap of 80. So what exactly overlap? The overlap makes your chunk connected. So what if you don't do the overlap? So let's say you have the chunks of 2. First chunk contain 500, second chunk contain different 500. So it is very much difficult to say this chunk and this chunk has any kind of content, right? So this is a disaggregated kind of knowledge. And when the retriever try to retrieve the data, right, it will retrieve the document, and maybe the data is unrelated, it may not retrieve, right? So it is very important to have this kind of chunk overlap so that you have the continuity in the chunks and it will not find the discontinuity in the different box. So you can consider chunk is a kind of virtual storage in which you have 500 words. In the again the second had 500 chunks, but the both the chunks are related to each other, so you keep some kind of overlap. So 500 here, and out of 500 from first chunks, 80 words will be available in the second chunks, so you have the continuity. So with this continuity, the whatever chunks going to create it, let's say the 5 chunks is created from this document, we can say that these 5 chunks are related to this knowledge base.md because of this kind of overlap, and we'll have the continuity. This will help to understand what is the length of my chunks. So we will execute that, and then once I have the chunks, I'm going to pass the chunks and the embedding. So these chunks is my data. With the help of embedding, I'm going to convert the chunks into the embedding, and then we will store this embedding into the FAISS vector database. Note that as I mentioned embedding, but it is nothing but the vector format, because machine LLM or the machine can't read your data in a text format. They can do the reading in the vector format only. So that's the reason LLM require this data into the vector format. We have to use the embedding for that to convert your data into the vector format, and this will store your chunks into the vector store. So let me rerun this and see how much chunks are available after we convert this knowledge base. So as you can see, the 9 chunks been created from this knowledge base. Now let's try to see what it will come. So now I have already initiated my vector store. From vector store, I'm using the function called as retriever, and I'm saying the search Groq as a 3. So if I ask any question, based on the question, it will retrieve the top 3 relevant chunks, right? For example, let's say I'm asking a question like what is a transformer, right? So based on this transformer, it will retrieve the data. Okay, so for D in a retriever dot invoke, what is transformer, and I'm pasting only the first 80 lines, okay, from the page. I do not want whole data, right? And that's why I'm retrieving only first 80 words, not lines, sorry, first 80 words. So let me run this, okay, and see it retrieve the data from first 3 chunks. What is transformer? This is the answer. What is neural network? This is the answer. And what is RAG, right? So I have asked what is transformer, but based on my question, it retrieved first 3 closest chunks. Now if you look at my knowledge base, it has all this data, but it only retrieves the answer which is closest to my question, and definitely it is accepted. As still, if you see, the neural network is something not a transfer, but still retrieve, because it has the closeness as compared to other, and we have said 3, and that's why it comes with the 3. If I say 2, so it only give me the 2 chunks related to my question, right? Similarly, if you tweak this parameter accordingly, it will give the answer. I hope now this gives the confidence your retriever works. Now the major part comes here, and that is the basic RAG. So first we will use the chat rock, so which will help us to use the LLM model from our Groq, then prompt template, which will help to create our prompt, then structure output parser, which will give the it will parse our output and give into the string format, because we want answer in the string format, right? So this structure output parser, sorry, not structure, string output parser will help to convert the answer from LLM into the string format, and then runnable pass through. So this runnable pass through helps to return input data as is it. Okay, so whatever input data we are passing to our RAG, basic RAG, it will return in a as it is format without any changes. So let's try to understand line by line. So as I mentioned, the chat Groq here is saying that we will use this llama model and temperature as 0, because we do not want any kind of creativity as such. So we want the it should select the topmost answer from my from it should generate the answer which is closest to the accuracy, right? So this is a model of llama 3.3. Then now it's time to build the prompt. My LLM is ready. Now second requirement, build the prompt. So for that we are using the chat prompt template from LangChain, and this is how I have created the prompt. So what I'm saying, answer the question using only the context, right? If you do not find any context, say you do not know, but do not give answer based on your knowledge. And then we are passing context. This is my context is a variable. So whatever the data is retrieved, it will retrieve in the this variable called context. And then I'm passing question into the question. So question and context is a something that I'm going to get it from the user. The question is I'm going to get from user, and the context is something that retrieve from the vector database. So this prompt will help you to do the answer, and the answer will form here. The next function we are going to use the format docs. So whatever the data we are going to retrieve, we want to come in this format, right? So join the page content for the docs. So whatever docs we are going to, so we have created docs, right? So this is what is my docs that we have already created. So we want this doc to be go in this format, right? So we are formatting docs in this way. Now let's try to so this is a RAG chain. If uh, no one aware, let me explain. So I want my context here. So how I can get my context from the vector database? So that's why I'm the vector database here called retrieve. We already initialize the vector store, then variable retriever. So that's why I'm saying I'll get my context from my vector store, okay, with the docs, that is format docs. So the whatever docs I have, right, that I have used to store in vector database, I will pass here. So this format docs, so whatever docs I have initiated here, right, I will pass to this, so that it will refer this format docs and retrieve from my vector. Then I have question. This question will run through this runnable pass-through, because the reason I use runnable pass-through, because we want this return input data as is or assign new dictionary keys. So just for a simple explanation, we want our question to be not modified. It should go as it is, and that's the reason we use this runnable pass-through library, or you can say functions from LangChain. Then I will pass my prompt and then LLM, and then I want output in a string format. Now this will create my basic RAG. I think it's very easy. So my basic RAG will come from my one liner, right? So I have my LLM, I have my prompts, I have my context, I have my question. I just need to pass in this chain, in this pipe format, and this will create my RAG chain. Let me run this. Okay, so this will help me to compile all this code. Now my basic RAG is ready. Let me ask the question. So to ask the question, I will use invoke method of RAG chain, and I'm asking what is RAG and why does it the hallucination. So let me ask this question. So based on this question, it will retrieve the data from vector store and pass it to the, and I have the prompt and LLM, and this prompt is made up of this context and this question, and based on that it will hit the RAG. So as you can see, it's a retrieval augmented generation is a technique that gives the language model access to external knowledge base. Okay, so let's see whether it is from our knowledge base or not. So let me search here. Okay, so see from where I got this, it reduced the hallucination. So what is wrong? Okay, so the retrieval augmented technique that gives the language model to access the external knowledge base, right? So you can see it refers the this line from this thing, right? So it is from the knowledge base, not from the LLM, right? It just, what LLM does, it just added some extra layer of words, extra things to just to make your answer in a easy format. So format it changed, but the data refers this knowledge base. So fantastic. My basic RAG is fine, but the question comes that how it will validate whether my answer is correct or not. Again, as I mentioned, basic RAG has the problem that it can't choose the source. And to overcome, we will use the agentic RAG. Now let's try to see how agentic RAG can be implemented. Now for this agentic RAG, we are using some of the again function called as typedict, which will help to utilize our dictionary. Then we will use LangGraph. So instead of LangChain, we will use LangGraph because this will make the implementation of agentic RAG. And then we have the state graph, start, and so if you haven't watched my LangGraph, I would encourage go and watch the LangGraph couple of videos where I have explained in detail explanation what is start, what is end, what is state graph. Now we have to declare or create few function, right? So first we are going to create some function called as the web search. So what this web search will helps? So this web search will helps to get the answer from the internet, right? So this is the line of code which will help to get the answer from the internet if it is not available in the database or any kind of tools. This is what the web search is, and for that we are using the DuckDuckGo search. Then we have to create some kind of a state graph, right? The state thing, the thing that is available across the whole node of my LangGraph. So I want there are some couple of information that my whole node is available. Now if you look at this agentic RAG diagram, in this agentic RAG, all these nodes you consider query, rewrite query, update query, LLM, retry update, source DB, all these are a kind of nodes. And I want whenever actions is being taken, this information my all node must be aware. And that's why we are using this class agent state, and we'll use question. This is something that I want my all agent node should be aware. Then updated query, then source, then context, then generation, my retry. I want all this information to pass across my agent node. So let's run this. So this will create my LangGraph and create my class called agent state with this available variable. Now it is very important to create those boxes. As I mentioned, we are going to create those all these boxes, right? The first box is the rewrite query. This is again an agent, right? As I mentioned, it's an agentic RAG. So we are going to agent for this rewrite query. But for this, again, as these are agent, but this agent is nothing but the LLM with some kind of tools, right? So rewrite query, I'm going to use chat prompt template from my template, and I'm asking rewrite into clear standalone search query and return only the query. So I'm asking my LLM whatever user asks the questions, right? These questions we want to be rewrite into the searchable query. It should not be a statement, or it should not be a kind of half ended. It should be convert the query into the searchable format so that we can search. And then we pass the prompt, we create this kind of RAG chain. So we earlier have already have created this kind of RAG chain, right, using the line. So similarly here we are creating those kind of query formats. So I have my query, I'm creating this pipe p, that is my prompt, then I'm passing to the LLM that we have already initiated, and I want my output should be in string format, and I'm asking using invoke method. So this invoke method, for this invoke method, I have my queue, that is a query, and I'm passing the questions. So from where I get the question? So we have already created the state, right? So from the state, we are passing the question to this. If there is any spaces back and forth, we are just stripping it. So this way, this combine whole chain and I'm passing this query. So if I pass everything, it will give me the result. So it will give me the rewritten query. So I'm just printing this rewritten query here, and then we will have the updated query. So this way, this will my rewrite agent. So when I say agentic RAG, it's not just one thing. It's a combination of agents. So my first agent is ready, that is called as the rewrite query agent. Okay, so rewrite query, we write this rewrite query. My second agent, if you look at my picture, that is called as the decide to retry, right? So this is my second. Whether do I need to retry or not, right? So which source? So let's say if I say require more details, right? Require more details or not. So this decision has to, right? So I have my rewrite query that already written. I got my updated query, but now next agent I require need more details. So decision whether to retry or not. So this come here. So let me write. So this is will be my decision need more details or not. Fine. So what? Again, I have my prompt template. For that, I am using prompt. Does answering require external facts, data or not? If answer should be in the yes or no format, that is also I am passing here. And my question, which will be the query. Now we have already got the query, right, from my previous agent. I'm passing this question in a q colon q, which is in the dictionary format. So this question will go to my prompt. So my prompt is inclusion of this along with the updated query. And again, I'm using this piping. So this piping will help me to get the answer. So again, if you look at this, in invoke, I pass the question, but in my this invoke, I'm passing the updated query. So whatever updated query is there, right? If you look at this, my updated query will be the queue here, the return, which already been there. I am passing the state of updated query, right? So this will make everything, right? Now, if D is start with the S, if the decision is S, right? Then I'm mentioning the variable flag called need, right? Otherwise, it will print need details S if need, otherwise no, right? And it will return the retry if need, else it will return the generate, right? So based on the decide to retrieve, it will consider will return the two keywords, that is retrieve. So if the answer is need, then it will say return the retrieve, otherwise will return the generate. So my second node, that is need more details agent is. Now what is next? Next is a route to source. If you look at the diagram, I have route to source. We have to route, right, to the specific, whether it's a vector database or whether it's a tools or whether it's a internet. So this is my routing agent, right? Again, as this is agent, so I am creating the, sorry, should be comment. Now again, I'm creating the prompt. So here I'm mentioning the vector store nodes on ML. So my if it is a vector store, then vector store has nodes on ML, neural network, transformer, RAG, embedding or Groq. Web, that is anything else, and reply one word. And this is my question. So I have my updated query, right? So based on the updated query, right, it will return whether it's a vector store or whether it's a web. So again, the same thing. Here is my prompt, LLM output in the string format, and again I have to pass the updated. Now, if the answer is web, okay, if my routing agent returns the web, then it should return web. Otherwise, it will return the vector store. and here I am printing my source. So based on the query, I will decide whether I'm going to use web or whether I'm going to use the vector store. And this is my routing agent. So the next is the retrieval agent, right? Well, agent. Now I have my query in updated. So my state, the state is my is something dictionary. From that dictionary, I want the value of updated query. So from the updated query, I retry the query. If my updated for this query, okay, please note that if for this query, if my source is a web which I have got from the routing agent, then I will use the web search. If it is not web, okay, then so this is a CTX is nothing but the context, right? If the answer from my routing source is a web, then it will search, it will call the web search tool. We say the web search tool. Otherwise, it will retrieve from the vector store. So we have already created the retriever in a basic RAG, if you guys remember, right? So we have retrieved the data from my vector store and we create the context. And this will help me to print the retrieve from. So this will help me to understand from where you have retrieve, right? Whether it's a web or vector store. This is just for our purpose. This is a stage number 6. If you look at this diagram, now I'm talking about the stage number 6. So till now we have completed the rewrite agent, need more details agent, source agent, now the vector store agent. So this retriever agent is done. Now the last stage, that is something is the generate, not last stage but the pre-stage, right? Now we have to base on the context. Now I got the context, whether it's a web search or whether it's a vector store, whatever. Now it is important to generate. So this is my next agent, that is called as a generate agent. Now I have to first pass the state, and from the state dot get I'm passing, I have to get the context. If no context, I say no context and pass the context. Now again we have to create the prompt. So what I'm saying in the prompt, answer using the context when helpful. The context I'm passing the C, my question is Q, and then it will generate the answer. And again same thing, right? The same pipe of declaration of it. And this will help to generate the answer. Please look at this dictionary. Here I'm passing C as a context. So my C contain the context, my Q contain my question, which will passes to the LLM with this P of the prompt template, and A is nothing but the answer. This will generate the answer of step 8. Look at this step 8. Here we are generating the. Now you can see I'm having the two things, whether first is a context or no context. So during this step, that is need more details or not. If you look at the need more details, that is my decision agent. If say no, right? If say no, then it will directly go to the generate, right? It will return the generate. And if it is returned to generate, then it will come to this generate agent with the no context. Okay. Now, next is the whatever answer is being generated, whether it's accurate or not, that is something to calculate, because we are saying it's a agentic RAG. So generated answer we need to evaluate. So for this is called is my generate agent, right? So again we have to check the if state. Second, so red answer, if retrieves is greater than 2, so we can set the retrievers, right? How many times we want to retrieve, right? If it is greater than equal to 2, then it's okay, otherwise return acceptable, right? So max retrieve, it should not be happen that my retrieve is more than it has not retrieve. So we make sure that it should retrieve, right? It should retrieve, otherwise it will fail. So I'm creating my state of retries, and it should be greater than at least 2. It should try more than 2 times. And now here I'm passing again using LLM. does the answer relevantly address to the questions? So for the grading, again I'm taking help of LLM and see whether the generated answer is relevant to question or not. If it is yes, fine. If it is not, then it will take the action. For that, I'm passing Q and the answer. So again, same thing. Here I'm passing my question and the answer. And I am asking LLM itself whether the answer and the questions are appropriate or not. If the answer is start with the S, then it's good. If not, then we again go and do the retry. So in the retry, you look at the diagram. If answer is relevant, yes. If it is not, then again it will go to the rewrite. And we want this retry should be greater than 2, right? If it is yes, it's fine. If not, then again it will go and rewrite the query and it call the rewrite query. Great. Now this is a one function which will make sure that my retries will updated, right? It will keep updating. That is first retry, second retry, third retry. How many times this retries happen, because we wanted to store that retry, right? Because we are limiting we want that max 10 retries, right? Let me first execute all these agents. No error. So if you can look at this, these many agents get it, right? So if someone asks how to create the agent, this is the way that you have create multiple agents. Okay, so these many agents we have created. So let's count it: 1, 2, 3, 4, 5, 6. 6 agents we have. Now the work will not finish here. We have to again make the connections between these different agents. In isolated way we have created, but there should be a handshake between these two agents. Each agent knows what is my work, but unless until we do not pass their work to different agent, this cycle will not completed. And this is where LangGraph help us to create those connections. Now nothing else, there is nothing. Hard part is already completed. We are just now doing to create this connection, right? So as I mentioned, we have created these different nodes. So this is called as a g.add node. Okay, this is the initialization of your LangGraph where you are passing agent state. So we want so all these value that we have created, question, text, updated query, context, and everything to be part of this. We want all the node to be must be aware, and we are creating this node now. So rewrite query, I'm passing. So I'm creating a node called rewrite query. You can give any name; it's up to you. But I want this to be say. So I'm giving the name to node my rewrite query and passing the function called rewrite query. Similarly, route to source is my name to second node, right? This one, and then route to source. So this way I'm creating the different nodes. Now once I have created node, now it is very important to have the connectivity. So I am going to add the edge from start. Start is the first node from where the flow will start. This start will connect it to my rewrite query. Then after rewrite query, I want the conditional edges. So there are two type of edges in the LangGraph. One is a normal edge which just take the connectivity, but the conditional edge is something a decision edge, right? It will have the multiple things. We will do the visualization in a minute. Okay, but the conditional edge is from my rewrite query to decide to retrieve, right? And based on that, it will check whether it passed to the route to source or whether to generate, right? We have talked about that. If it is require retrieve, then we'll go to the route to source. Otherwise, it will connect it to the generate one. Then we are adding the next edge from route to source. If it is a route to source, then it will connect to the retrieve node, and then retrieve node will connect it to generate. Again, from the generate, we need to have the additional conditional edge, right? So from this additional conditional edge, we are connecting generate and have the condition of grade answer. If the grade answer is end, if it is say end, then it say acceptable. If it is if the grade answer is not correct, then we will go to the bump retries, right? So it will keep adding the ticker to ++1, and this bump retry will again connect it to the rewrite query. So this way my graph is ready. Let me do the compilation and see whether it's in error or not. No error, that's a great. Let's do the visualization of this. See, everything is very nice. So we have started with start. It will go to the rewrite query. Okay, and then here we have decision agent. Okay, if it is retrieve, then it go to the route to source, otherwise it will connect it to the generate. Now if you from the diagram you can also see, if it is normal edge, it's a dark edge. If it is conditional edge, then will be the dotted one. So dotted one will be the conditional. If there is no rewrite is required, it will connect it to the generate. Then it will go to the route to source, then it will retrieve the data from my vector store, and then it will generate, right? Now again in retriever we have two retrieval, that is one is the web and the second is the vector store, right? So based on that we can decide. So if you can look at this retrieve, right? So route to source and then retrieve. So retrieve has thing, right? So in retrieve itself I have the two things, whether it's a web or whether it's a context, right? So it is handling those things internally. And then last is the generate. If answer is acceptable, it ends. No, then contact my node, that is bump retry, and again write the query. Everything is fine, code is okay. Let's try to check with the three questions. So first I have asked what is the transformer. So definitely this is something that my knowledge basis already has. Second is the who won the 2022 FIFA World Cup. Third, what is the 15 times. Okay, I'm using agent, that is something one single entry point for me. In passing this question, retrieve, currently I haven't done any retrieve, so I mark the 0, and then output will come into the final. So let's try to see how it works, right? So when you if you look at this output, what is transformer, right? It first rewritten, right? Because we want our query should be searchable, right? So it rewritten into the what is transformer. Then it goes to the need details. Do you require more details? No, doesn't require more details. So it's generated and the relevant answer is yes. So say transformer can refer to different things depending on the context. Okay, and in general it can be electrical device that transfer electrical energy from one circuit to another through electromagnetic in computer science and machines. So this is what we got the answer because LLM is already aware. However, we expect to refer the transformer something from our knowledge base. But the transformer is already aware, but it this time it takes transformer as a something, the electrical transfer. That's fine. Second, we have asked who won the 2022 World Cup, right? So it rewritten into the 2022 FIFA World Cup winner, okay, into the searchable query. Do you require need more detail? Yes. This time it goes to the web, and now there is some issue with my package. Has been renamed to keep install. Okay, so I think package has renamed to DDGS. We need to install this. So let me install it right away. Okay, so install. Okay, so if you guys see such an error, you can fix then and there. This is again one of the good learnable things, right? Meanwhile, let's try to understand other things. Okay, what is 15 times 12, right? So it's written 15 into 12 into searchable. Require more details? No, it generated and gives the answer 180. Great. So we have seen it uses the web and it uses something. So let me use my knowledge base and see if it has some able to create from take from the. So let me ask what are embedding. Let's see whether it will take the knowledge base or not. Great. This time it takes, this time it understood. It's something that I'm not aware. If you look at this, it rewritten into the embedding and RAG in artificial intelligence. This time say artificial, and this is good, right? And need more details? Yes, maybe the model is not aware about that. Sources is vector store, retrieve from vector store, generated. And is the answer is relevant? Yes, and the embedding and RAGs are related to concepts in a natural language processing. Embedding refers to the list of numbers. That's great. So it's retrieved from our vector store. Second, we kept the same thing, but I think still this time the package is not, maybe some issue, but yeah, I think you guys can check local and just install. Oh no, I think it's done. I can see with DDGS or right form and retrieve from web. Oh, this works. Sorry, I thought again giving the same, but no, it's not that way. It derived from the web, and Argentina won 2022 World Cup defeating the France 4-2 in a penalty shootout after match ended 3-3 after extra time. That's great. That's literally great, and everything knows. Now I hope now you're able to understand that all these steps. So what let's summarize this. So RAG is a basic RAG. Okay, RAG is definitely a basic RAG which will retrieve the answer from your data, from your vector store and generate. But there is no validation, no context checking, no source checking, right? But the agentic RAG is something is really work in a production which will gives the capability to validate, to update the query into searchable format, to generate the answer, to check the different sources and validate whether the answer is relevant or not. So definitely agentic RAG is something the Go approach in the production implement. I hope you like this, like my explanation. Now you understood how the agentic RAG is a different RAG. If you like, please click thumbs up and please comment and share with your friends and family. Thank you so much.